Yeah, no, absolutely. I think it's the best option. Okay, perfect. Can you guys all see the screen? I assume. All right. So I assume you can all see my screen. And yeah, so hi everyone, and thanks for joining me in this event today. And as the title hints, we are going to discuss about working with data on the Stellar network. More specifically, we are going to take a look at the network data layout at a very high level, then discuss the role of indexers in the Stellar ecosystem, which is quite domain specific, as we will see in the next minutes. And in the second part of the event, I will introduce you to the Zephyr virtual machine, and I will live code a community selected program to create a public index, and which I believe that this program will be the Soroban fees comparison with Stellar Classic, but I'm not sure yet. So before starting, for those who don't know me, let me introduce myself. I am Tommaso. I am the co-founder at Xyclu Labs, where we build Stellar-related software. So, for example, we've built the Xyclones protocol. We are building Mercury. We are building, obviously, the Zephyr virtual machine. And yeah, besides that, I'm also a part-time Stellar Development Foundation external contractor. So I work with Tyler on stuff like the RP Siege, Soroflare, Fast Chip and Out of Control, and the Soroban Quest. And lastly, I'm happy to be a member of the Stellar community, and I thank Dana from the SDF for co-hosting this event and the community for participating. So, without further introduction, let's dive into the network's data layout. So, a good way to understand how Stellar divides its data, how it structures its data, is to understand that on Stellar, the Stellar core instances are dividing their data, they are splitting their data between current data and historical data. And another way to understand this concept better, or at least to get to start understanding this concept, is to analyze the difference in the terminology of the ledger in Stellar and on most other chains. Because while on most other chains, the ledger, which is always the current state of the blockchain, right? But on other chains, in order for this state to be aggregated from core nodes, you will need to consult history. On Stellar, on the other hand, this current state, the ledger, is stored directly within each Stellar core instances database. So while you're running Stellar core, what happens is that we're also running a Postgres database which contains the actual ledger. And what is within the ledger? Well, within the ledger we have all the ledger entries of the network. We have account entries, contract data entries, trust line entries, contract code entries, time to live entries, and so on. And these are the only state of the network that is needed. I mean, this is the state of the network, right? And it's the only data that is needed for peers to achieve consensus for the next ledger close. And this data, this local data, it's read and written by Stellar core instances along with the network lifecycle. So as new transactions get applied, new transaction sets more specifically get applied, this local database is consulted and written. And yeah, so that's pretty much how the current data looks on Stellar. But what about the historical data? Because of course we need to be able to access the operations that we've made on the chain, transactions and so on. And these, all of this historical data is retained in archivers. archivers are long-term storage services. So, for instance, they could be, for example, a file system server or really anything that is fit for storing large amounts of data. And archivers are crucial for, not as crucial as validators, but they are also very important for the decentralization of the network. Also because, a good way to understand this is that peers within a group, unless they are catching up with data from, with data whose integrity is verified, so from archiver data, they will not, unless they are starting at the same time, they will not be able to reach any consensus within this group, right? So they are quite crucial for the ecosystem. And how does this data how does the historical data reach the archiver from the Stellar Core? What happens is once Stellar Core closes each ledger, the metadata, the meta of what really happened between the state n and the state n+1, the new ledger. So what happened within that period of time gets pushed to a checkpoint, which every 64 ledgers gets pushed to the archiver. So we could say that the archivers are getting updated about every 5 minutes on mainnet. And an important takeaway here about archivers is that they are organized in HAS files, right? So we have the root HAS file, and we have individual HAS files, which are basically our checkpoints. And this is not really like an API for clients to use to access historical data, because they would need to download each checkpoint and then decompress it and handle it, and there are a lot of nuances of doing so. So it's not scalable for obviously a client to interact with this. These are obviously, these are used, but not like directly from clients, right? And another important takeaway regarding the metadata that gets pushed to archivers is that since the beginning of Stellar until Protocol 20, all the transactions operations all had the predefined structure. So the logic with which each operation modifies the interested ledger entries has always been the same. This, however, changes with Protocol 20, and we will see in a bit why. But before, we're going to take a look at how the when building on Stellar Classic mainly, and for ever since Stellar was born until now, until Protocol 20, we will see why the existing infrastructure is enough. In fact, you generally have 3 options when working with Classic. For simpler applications, wallets, for example, you can use explorers like Horizon or Stellar Expert to retrieve the data about certain transactions, users, and so on. And given the simplicity and the predefined structure, as we already mentioned, of the data structures and the quite linear flows with which these modified ledger entries, this wouldn't need any complex queries, right? On the other hand, for more complex, as it doesn't need more complex queries, you can generally use Horizon or Stellar Expert, which are built for that. On the other hand, for more complex applications, since the logic of the transaction generation generally happen in a backend, perhaps, or at least it encompassed the backend, this part of the logic was off-chain, and this meant that many services maintained their own databases for faster and easier and more complex data retrieval needs, and they could do so because even though the network is decentralized, the way that the transaction was, the whole interaction wasn't completely decentralized. At least it encompassed the a backend generally. The other alternative was, is to use your own Stellar infrastructure, and at that point you can ingest and store whatever you want, pretty much. However, with Protocol 20, more specifically when working with smart contracts and in a decentralized environments, things change because you can use explorers or the RPC to retrieve the data. For example, the RPC is excellent for retrieving current ledger data. But these are not generally fit for an efficient and deep, complex and granular querying needs. It wouldn't be efficient to craft complex queries on these services, and it's not even possible as of now. And this is something that is needed when working with smart contracts, because we have this whole new world of the user-defined logic, developer-defined logic, and this of course means that we have, developers need to be able to access large amounts of data, and they need to be able to make deep queries, nested queries, and so on. And the second alternative of like centralized workflows is not possible anymore, because given the determinism of the chain, smart contract invocation will never encompass a backend. So this isn't really an alternative anymore. And for running your own Stellar infrastructure, I guess that nothing really changes. If you're up for building your own ingestion and APIs and so on, you can definitely do that, and nothing will change. But what does this mean is that you either build and maintain your own Stellar infrastructure, or you can rely on an indexing service. Though on Stellar, indexer do have a very domain-specific role, even though we never really had what the indexers that other chains had as of now. And we'll see why and how in a couple of minutes. But we'll start by enumerating what an indexer should actually do. In fact, it should be the intermediary for applications and services to access network data in a way that is fast and efficient. And in order to do that, we have enumerated 4 principles. So the indexer would need to be very efficient. So the API needs to be fast. It needs to be able to work with large amount of data efficiently. It needs to be able to craft complex queries, deep and nested queries, craft granular queries while still keeping an incredible efficiency. And it should also be flexible, so it should be customizable, given that the developer has its own logic when modifying ledger entries. They should have also a good degree of customization when working with the data that they are writing to the chain. So it needs to also work out of the box with clients. And it also needs to be cost efficient, because less costs mean that there is less infrastructure, which means that there is less maintenance costs, so even less costs for the users, basically. And theoretically, in order to wrap and max out all of these characteristics, the indexer would need to have a very lightweight infrastructure, so it would need to store the least amount of data possible. And to support this argument, we can bring into the discussion how the SDFs, very own Horizon developers, noticed that more than 9 users out of 10 only access recent data, so data within the last year. And they were even considering trimming their history to make their service more sustainable. So this gives light to how a lightweight infrastructure makes up for more efficiency, and we will see this better later, though this is still an interesting argument to bring to the table. And practically speaking, though, when it comes to indexing, and this is something that we've always witnessed also on other chains, managed indexer services don't know which data will or will not need to be queried. For example, they are also powering Block Explorer. So they won't take the store less data path because they need to provide access to full history, not knowing what to ingest in the first place. Nevertheless, as we previously mentioned, in Stellar there never really was the need for the data retrieval, the efficiency that's offered by indexers. So that's why leading Block Explorer services, which again are generally fit for most classic related data needs, this led them to optimize and craft their APIs without the added complexity of an indexer's API. And as a result, since we already have excellent explorers in the ecosystem, for example, we have Horizon, Stellar Expert, which are not even just explorers, they also allow for more like to fetch offers and so on. So given that we have these excellent explorers, there is no need, even after Protocol 20, for an indexer to overlap with their functionality and to store data that will likely never need to be accessed through the indexer. Think for instance that most Stellar Classic data will never need to be accessed with the efficiency that the indexers provide. And at this point, knowing that on Stellar an indexer won't have to power an explorer, if only there was a way for an indexer to know in advance which data would have a use case in its database, the indexer can avoid indexing full history, thus maintaining a very lightweight infrastructure, thus maximizing the 4 characteristics that we mentioned to their full extent. Again, efficiency, complex queries, and so on. And all of this, the indexer would do all of this with, while still providing the crucial functionality that's what's missing right now, of being the efficient and fast gateway between applications and the Stellar Networks data mainly for Soroban related needs. And this room for the optimization that I just talked about brings us to Mercury. Mercury is the indexing service that we at Cyclo Labs are building. We've been building it since last year, and we've built it tailored for fitting within the Stellar ecosystem, following the principles we already talked about, therefore without overlapping with the functionality that's already offered by well-proven services that existed in the ecosystem for years. And to achieve this, we still had to solve the problem about knowing in advance which data to index. And this is where we came up with the concept of subscriptions. So subscriptions basically allow our clients to start targeting and indexing the specific pieces of data that they require. And this is the data that effectively has a use case when stored and structured in our database, and is in fact the only data that we store. In fact, subscriptions work simply given the strict determinism of the chain, according to which developers already know which data they will have to store before even deploying. So for example, let's say I'm working with contract and I want to track the supply for that contract. I know in advance which entry I will need to track even before I can deploy my contract. And this, this concept of subscriptions again work pretty simply by developers subscribing to data, and then after they have made the subscription, their data starts getting indexed on Mercury, and they can retrieve it efficiently with complex and deep queries and so on. Though, what about the data that was emitted before the subscription? Because again, I've been myself in the situation where I deployed my contracts, I deployed the protocol, and then I'm testing it on chain, making sure it works correctly, making a few deposits and so on, and then I would like to start working with the data part. So I would like to start indexing the events, ledger entries, and so on. The current subscription design that we described would require me to redeploy my contracts after making the subscription, and then retesting them on chain and so on. That's because even though I know in advance which entries I'm going to need, this doesn't mean that it's the first thing that developers think about when deploying their contracts, right? And we definitely understand that. So to also scale this usability issue and to have a better developer experience, we have implemented the concept of data retention. So each data structure, depending on whether the network demands it or not, will be retained on Mercury even when it doesn't have a subscription attached for a certain period of time. For example, as of now, we have contract events with 2 months data retention window. So after 2 months, if there isn't a subscription attached to this event, this will expire from our database. And so yeah, that's it for the current functionality that we have. But there is still one piece that's missing. So let's say that you are a protocol and you are migrating to Mercury, either from another service or you are starting to index. You understand that you need the querying and the data retrieval requirements that the indexer offers, and you want to switch to using Mercury. At that point, assuming that you have been more active for more than the retention window, there wouldn't really be a way currently to populate the Mercury database with your protocol's data. So, and that's something that we want to tackle, and we will do it soon after we implement data catch-ups. So users can request data catch-ups on request for some subscriptions, and this allows them basically to migrate data to Mercury. So now on to the next topic. So as you might have understood, Mercury is a managed indexing service. This means that we run everything from the infrastructure to the ingesting infrastructure, to the API, the backend, the database, and so on. And this brings many advantages, especially on indexers, where really the data that you access can be, the integrity of the data can be that you access can be verified, because of course it's all network data, so it's all decentralized. We just offer a way to retrieve it more efficiently. And having a managed indexing service, of course, makes a lot of things smoother. But however, it has quite a static structure. So the queries are limited to what the predefined queries are, even though we have a lot of customization on that point. We have deep queries, you can craft very granular queries and so on, but these are still all predefined queries, and the ingestion logic, the same argument can be applied to the ingestion logic. So there is pretty much little to no room for customization. And this also means that the current, that running a managed service might require manipulation or additional logic for the client for more complex data flows, which is something that goes against one of the characteristics that we enumerated for the indexers, so the flexibility. And to tackle this, we have built our very own Zephyr virtual machine. What is the Zephyr virtual machine? It's a WebAssembly virtual machine that is powering basically our whole cloud infrastructure. So what happens is that we have a VM that is able to execute user programs. So pretty much, you can write your program, deploy it to Mercury, and then the virtual machine will execute it. And through some host functions that you will be able to access through the SDK, you can read and write from Mercury's database. You can read the ledger meta for the current ledger, and you can pretty much do a lot of things within your guest program, right? And to do so, you basically just write your program and deploy it as it was like a smart contract, right? So this is pretty much means that you have your own indexing logic while running on the infrastructure of Mercury. And this opens up the room for endless customizations, as we will see also with like the live coding that will take place very soon. And so yeah, let's just before we get into the live coding, let's just look at how the life cycle of a program in our cloud is. So we have, first of all, Stellar Core streaming meta. So we have our Stellar Core instance streaming meta to Mercury, and this is where now we spin up the Zephyr virtual machines for all the modules that the users deployed, and then we apply the user logic defined within the program in our databases. And lastly, this means that as it is on our database, you can query your custom index or custom indexes with directly from our API. And we plan in the future also to extend the VM to have more features, to also adapt mix, for example, subscriptions within Mercury from Zephyr, or customizing your queries directly from the Zephyr program, and so on. So, but yeah, mainly what I would like to conclude with is that with Zephyr, you can, Mercury becomes quite a full, an indexer that has all the features that one would require if you're willing to rely on our infrastructure, because you have the Mercury, let's say, classic, as we're in the topic, you have the Mercury classic side that is optimized to work out of the box with most protocols and most data retrieval needs. But you also have the Zephyr virtual machine. So if you have very complex data flows and you need further customization and you don't want to manage your own infrastructure, maintain it, and so on, you can deploy simply a Zephyr program to manage this on our cloud. And this is something that we've also done for our protocol cyclones, which we will also share probably within the next week. So you will be able to also try out Mercury in action within a real protocol probably next week. So now thanks for having joined this event, and now let's go to the live coding part. So Dana can all right, I believe that everything went well, right? Yeah, I saw that it was pretty close. Let's see. We have I think that the winner is Soroban vs Stellar Classic Fizz comparison. And so yeah, let's start with that. So okay, so what I have here is a starter template. This is, if you wrote a smart contract, you can pretty much recognize the whole structure here. This is a Rust project because, given that it's a Wasm virtual machine, any program that compiles to WebAssembly really yeah, absolutely. Something I almost forgot. Sorry. So, given that this is a WebAssembly virtual machine, everything, any language that compiles to WebAssembly can actually run on our cloud infrastructure. However, as of now, we've only built the Rust SDK, so you can try and attempt to work on this from another language, but it will be quite a challenge, especially if you've tried doing so with Soroban. You'll understand that it's quite difficult. So we are here from Rust. What I want you to pay attention to is that here we are importing the SDK. We are defining some release setting to actually deploy, to build the binary. And then we have this zephyr.tom file, which is our project configuration file. So here we actually define all the database tables that we will interact with. And so yeah, because of course, as I mentioned, from Zephyr, the biggest utility is to, of course, like read and write to our database. So in order to do that, you need to declare which tables and which columns you'll read to. This is, of course, then all checked by our backend in order to make sure that is hashed by each user. So no one is accessing or writing tables of other users. But yeah. So since we will take a look at the pricing difference between Soroban and Stellar transactions, let's group a bit the ideas. Let me pull the Discord chat here in case any of you have any questions during the. So yeah, I've pulled the chat in my other screen. So if you have any questions as I'm writing the code, please do let me know. But yeah, the general thought of process when dealing with writing a new Zephyr program is first to understand what you want the outcome to be. So in our case, we want to be able to see the difference, and let's say we want to be able to see the average transaction fee for a Soroban operation, for a Soroban transaction actually, and the average transaction fee for a Stellar classing transaction. So we will have our table, and now I will get a bit into the whole serialization and deserialization that happens on the SDK, and also that will happen on the host environment in a bit. But then let's first define our table. So maybe let's call it stats. And then we have to define the table name. So let's say we want it to be average fee. And so this is actually probably the only table that we will write to within our Zephyr program. So we can go ahead and put it already here when defining one of our tables. And what we want, so I guess that to calculate the transaction fee for Soroban and Classic, what we really need to do is to go through all the envelopes and their meta, and then extract the actual transaction fee, because we don't want only the base fee or the declared fee, we want the actual transaction fee. So we need to go through the metas of each envelope. We need to make sure that it's successful, and we need to make sure that we are calculating the average cost, right? So let's define, okay, so let's actually start. Okay, so I think, but let me know in the chat if you don't think the same way, that aside from also taking the average fee, transaction fee, we could also make an aggregation of all the transactions. So see in testnet really how many transactions were Stellar Classic transactions and how many transactions were Soroban transactions. So I'm going to create a column here, Classic and Soroban. And this could be two large numbers. And then, okay, so let's start by defining the fee for Soroban. So fee Soroban, let's make this actually floating so we can see more. So Morgan, you're saying, let's see how many contract transactions. Yes, non-contract transactions. Okay, yeah, that makes sense. So we can split between contracts. So another one thing to note about the Zephyr VM is that we are actually, for now at least, we are relying on Soroban symbols. So all of this data that is then, I mean, our macros get it and they put it within our more lower level functions, but everything is a symbol here. So we need to be careful with the amount of characters that we use, and with the also like the special characters that we use. We plan to actually extend symbols in the next releases because we already support and in the Zephyr VM we support multival, which is a post MVP WASM feature which will allow us to write symbols that are longer, and since we already have it enabled for other reasons, we will also have it for symbols, because as of now we cannot really call these column contract invocations because it's 1, 2, 3, 5, 6, 7, 8, 9. Yeah, okay, so contracts makes sense, and with other we probably pretty much mean anything that is state expiration related. So okay, so this is fee for Soroban, and Morgan, you were saying like the fee for the average fee, you would keep the also having the average transaction fee for only contract invocations, or also or keeping like the fee only for Soroban in general and for Classic in general, rather than also splitting Soroban within contract invocations. Okay, in general. Great. And then we can call this other one fee class 1, 4, 6, 7, 8. Great. And we'll also make this a floating point number. So yeah, this is what we want to end up with. And ideally, since unless we do need to keep a record of how this progresses over time, we could also even have a table with only one row to keep track of all this, and without even actually writing a lot of data to the database. So also it's also making the execution cheaper. But if you guys want to also see how this evolves in history, we can do. Yeah, I mean, I'm using floating point numbers here. First of all, to showcase, I mean, that one might think that this is quite similar to Soroban. It's not. It's actually much easier than Soroban is. And you can also, given that the goal of the binaries is not to be as small as possible, because that would mean a lot of other inefficiencies for dealing with large amount of data. And so I would also like to showcase this and to make the fees probably even more precise. But yeah, I mean that you're probably right that we could also use here the integers, because these are structs anyways. So yeah, we'll adapt to this. So so yeah, let's actually like get started with this. It's taking already too much time. So one other thing to note, sorry, and then we will start, is that we have this onClose function, which is this function that gets called by default by the virtual machine, and we have here this no mangling feature, and then exposing this to the C API. which, I mean, if you work with stuff like Wasm, Pangent on Rust, you've already dealt with this. So yeah, let's start by defining our client and our environment client, which is pretty much doing the same thing. I mean, it has the same role of the environment client in Soroban, if you think about it, because it allows to interact with host functions in a way that is simpler. So let's actually start by, as we are receiving on close for every new ledger.txt close, a whole new transaction ledger meta with all transactions and their fees and so on. I think that a good starting point for this is to calculate the average transaction fee for average transaction fees for each ledger as we receive it. So that's okay. So I think that on our environment we export this reader object that is a helper for working with raw XDR data, because I mean, we want the ZFVM to be as lower level as possible, because it enables for I mean the really complex stuff, complex workflows and so on. But there are also, I mean, working with raw XDR data is requires a lot of nesting, and we also have this reader object that simplifies our life for stuff that is more standardized. For example, we now require all the envelopes with their metadata, because we want to get each envelope and also want to get the meta to see if the transaction was successful, and also to see the actual fee. And these, sorry, what was the return type of these? Okay. So okay, so we now have our envelopes and each metadata associated with this envelope. So let's start by seeing the charged fee. Let me take a look. Let's inspect the XDR actually. So we have here result, transaction result, and fee charge. Okay, so this is what we are after. So let's define this. We have meta result plus result again, and then we have fee charge. Wait, so now we have the first part of the puzzle, right? Now we have to check whether this was successful or not. Yeah, the XDR is very. I mean, this is of course the Stellar's XDR, right? So it's not anything that is Zephyr related. But yeah, the XDR really is a lot of generated code. Anyway, so we want to make sure that this very specific envelope, right, is successful. So for this, we can probably use this one if I'm not wrong. Yeah. So let's write a match for this. So meta result, and then we have the results. And so I guess that what this really is a transaction result. Yeah, again, you have no idea how without like the reader object how much nested this can get, Morgan. It's yeah. So yeah, anyways, so let's get the successful variance in. If I recall correctly, is yeah. So we have the if this is the success, and then let's see if there is another this way TXP bump inner success. Okay. So this should be, I mean, feel free to correct me if I'm wrong. But this needs to be reference, sorry. Wait. Yeah, of course. Of course, we need to say that all the other keys are unsuccessful. So now, if we are successful, sorry, let's then match the envelope. Envelope here, and we have the transaction envelope. So this one we have X. This is version 1, right? Yeah. And then we have transaction envelope, fee bump. And I don't actually think, I mean, I don't actually think that the TXP0 would ever need to be included, or I mean, is it still running like on the ledger? Do we have TXP0 operation? Yeah. Do you guys know? Well, I'm gonna use them anyways. Yeah. All right. Okay, so I'm gonna count the also the V0, even though I'm quite sure I've never encountered a transaction V0 envelope in the last, I mean, since I've pretty much ever worked with Stellar. So what we want to do here, I believe that what we really need to do here is just counting the amount of operations that are Stellar related and the operations that are Soroban related. You have a question, Charles? Yeah, so this program, the module gets called, it will run once for every ledger. So like after you deploy it, it will be continuously running for every ledger. So we are actually exploring some stuff about this because of course we don't want to have our cloud, even though it's scalable and so on, we don't want to have our cloud to be continuously running lots and lots of programs, because that might actually slow things down. So we are thinking about approaching some conditional execution. So you're only running this program when you know that a certain, let's say a certain contract is within that ledger meta. Or the other approach that we were thinking was for each account to have only one program, because yeah, after all, it's like pretty much building your own ingestion. So why would you need more than one ingestion? So yeah, these are the approaches that we are thinking about taking. But again, this is very this is still very raw. All of this, also a lot of this stuff that we're doing here will hopefully be more user friendly in the future. There are still a lot of stuff that we need to do for this to be a really complete solution. But yeah, we are getting there. So I was saying that what we really need to do here is for all transactions count the operations and their fees. So I think that we can just abstract this to another function. Let's call this count ops fees. So yeah, we have here, we want to accept our operations. Here, v1, ex, v1, dx, here, yeah, transaction, we have the operations here. So we have, let's actually convert this to vector. We want to. It is always, yeah, you're right. It is always one operation, but though that's only for Soroban. So we only want, we want to count the operations both for classic, the amount of operations for classic, and the amount of operations for Soroban, and yeah, also the amount of operations that are contract related. So a vector of operations, and I think that we can, what we can actually do here is yeah, I think that we can just create some mutable let me think about this. I see your guys are writing in the chat Soroban transaction. No, okay, you're not. Okay, so okay, so what we can do here, I think that we can actually, yeah, we can have some mutable operations, so strict contract invocations, even without strict, it's not needed. And we initialize this to 0. We'll do the same for classic. We initialize to 0. We will do the same for the other one. Or even we could, yeah, we can keep the design as this. Yeah, I think that this will get to be inferred anyways. So yeah, yeah, this will likely be. For each ledger meta, this is definitely enough. But yeah, as you see here, these are then when within the database, these are all 128 bits, bit integers. So yeah, but for the one single ledger mate itself, yeah, it's definitely enough, because we have maximum of 100 transactions and 1,000 transactions or 10,000 transactions, yeah, and then a maximum of 100 operations per transaction. So yeah, that's enough. So other Soroban, and then let's also initialize the fees. Total Soroban fee, and let's make this total classic fee. Great. So now what we want here in our operation is for this function to take this as mutables, and yeah, this seems like quite a good design. Yeah. So we have here classic. I'm not sure. It's actually the cleanest way to do this. Do you guys have any like suggestions or whatever? Yeah, I mean, like what I'm trying to do here is like, since what we're going to end up doing here anyways is counting all the operations and the fees of the transactions, and what we always resolve to is a bunch of operations and the fee. So I thought that having like one function that takes some mutables as argument and then continuously writes to them would work great. But I'm not sure, is it the cleanest design we can have or not? Yeah, I mean, let's do this anyways. We will see if there is room for optimization later on. So let's make this operator to here. Then we have other Soroban total Soroban fee. Yeah, I mean, as the first prototype, it can always have like a not the most efficient design ever. I will load it this one anyways in a Zephyr examples repo, so we will see how this progresses over time too. All right, now onto this. So we are passing a bunch of operations. So I guess that's really what we do for operation. In operations, iter, we want to match the body, the operation, yes. Okay, so this is exactly where we are, I mean, we're splitting the Soroban related, the contract invocation related operations with the Stellar Classic related operations, because here we can pretty easily operation body and let's, I mean, given that there are much more operation classic operations, I'm just gonna mesh the Soroban operations and then count all the others as classic. So we invoke host function. We don't really need to have anything about this, to be honest. So we can, alright, actually we do, because we want to be able to keep, I mean, not all host function invocations are contract invocations, unless you, Morgan, meant like all invoke host function invocations, all of them. Alright. Okay, so then in that case, we don't need to check whether it's a contract invocation or it's a deployment or installation. So here we can, well, we will rename this later on. Then we'll keep this for now. So yeah. And now we need to add the total soroban fee. And yeah, this is actually something that we need from the transaction fee. Okay, so let's add another argument here. And this is going to be our EX fee. Now, let's do pretty much the same for TTL extensions. So here we have other soroban, and we're going to do the same. For store footprint extraction. And now all the remaining operations are all classic operations. So let's do this here and okay, so we now have our okay, so I reckon that we are near ending here. So you mentioned the helper organ. Like, what do you mean exactly? Okay. Great. So okay, so now it's time to simply count operation and fees. So we have v1 dot ex dot operations vector. Then we have the transaction fee, which is actually charged, and then we have classic. Already have here converting location here. Okay, makes sense. It's not inferred though. Maybe suspect E32. Ah, yeah, of course. Okay. So now it's just about doing the same thing also for fee bumps. Fee bump, we have to get transaction and then the inner transaction, if I recall correctly. Yeah, and this is a match arm. ISO, yeah. V1. Alright. And then it's pretty much the same thing here. Yeah, I was thinking that also probably analyzing how many fee bump how many soroban operations use fee bumps would be quite interesting. Well, maybe we'll add it later. Let's finish the current implementation for now. And so this one here, V0. I don't think this is the structure for V0 though. Oh, it is. Alright, so what we ended up with here is So yeah, it's the pretty much all the statistics we need for what you say? Yeah. Let's start with what we are. What we wanted to do in the first place. So what we got here is the everything that we need for the current ledger, but we know that we need to aggregate it for all the ledgers, right? With the database, so that it can count all the ledgers that it is running to. And okay, so I think that one thing that would be cool to have here is for the fees, rather than to have an average that is in a simple number, and then we should have to implement the average. We could try and use an exponential moving average, so that I can also showcase one of the features within our whole serialization flow, which enables our database to really also, our Zephyr program to also definitely directly interact with objects within its database structures, and we can do it automatically. So let's search for Rust image. So yeah, okay, so we have already this one. I'm going to use this one since it is an exponential moving average object, which I already used a couple of times for some other programs. So we'll resort to using this, also because I already know that this can be this potentially implements serialization and deserialization. So let's use this features. It was sorry. Right, so here, instead of having actual numbers, what we end up having is the exponential moving average object. And it is this one. And okay. So what we need to do now is basically check that we have at least one entry, if not created in the database, for our row. So we will take the current state of our database by calling env read, and then we will specify the object stats, which implements all the conversions through the macros. So what we have here is a vector of stats, and we want to check whether we already have at least one row. So we are going to use last here. If not, we are going to have to create it. So let's start by actually creating it, and then we will go about updating it. So let's fix Orban exponential moving average new. Right. Okay, so here we can specify a period. The period of the exponential moving average, so the amount of ledgers that we have the most impact. If you guys have any preferred period, let me know. For now, I will just make this constant. Actually, what type does it need to be? So I will make it let's say, let's make it every 5 minutes, every 64 ledgers. Let's unwrap this. Another thing that is really missing with Zephyr and its whole implementation is the is the whole testing infrastructure, because as of now, I mean, you could probably test this, but you would need to fill some ledger metas manually, and also have the database implemented and so on. So as of now, keep in mind that there really isn't any testing going around, and it's something that we actually want to tackle as a very next thing, because yeah, this is taking more than I expected. But yeah, overall the whole architecture of Zephyr is still very, very new, so it takes quite a bit to get used to this, and also like understand really the structure that's needed behind doing something. So yeah, let's hope it works, because again, there is no testing. So no, I'm kidding. This will work. So I think that okay, so here we are not really actually calculating the average TX fee though, right? Because we are just calculating the total fees. So let's say let's actually wrap this in something more like contracts plus other average sorbent and average classic. And we can do this here. And return so we have contract invocations, classic, other sorbent, and then we have total sorbent fee. Check the amount of envelopes, right? Yeah, it should be the amount of envelopes. I mean, to calculate the average. Though if we actually calculate this for each operation, yeah. So if I mean, which is actually even better, because it showcases this more. We can just divide this total sorbent fee divided by the amount of transactions. So dot contract invocations plus other sorbent, and then we can do the same for classic fee. We are doing a check diff because we are not sure whether there will be, especially for sorbent, whether there will be any sorbent operations in the yeah. I mean, I could actually also into this one. Alright, so I think we are quite all set. Finally. So here, if let's some equals average soroban, then this will be phi, else it will just be 0 because there will be no. This is 4K. Let's see which traits. We need to convert this to a floating point number anyways. Okay. So now we have average classic, which, I mean, the same thing works for these ones. And now we can finally write to our database our first row, so environment.put, and we are building stats classic, which is already classic. We have contracts, father, and we have fees, so Sorban and phi classic, phi classic, and yes, actually, okay. And this will write to our database. And I was almost forgetting this one. Okay. So this long line, yeah, these lines are really. I mean, I think it's also given by the fact that it's very zoomed. I would have to see how this looks once this is. I mean, it's rescaled to the current zoom, but yeah, there is definitely some long lines. So let's again get into this. So we have our row, which we actually need to clone in this case, I think, yeah. We have our previous, we have our previous classic, which is row.classic, and all of these contracts. All right. So we need to check if yeah, I would say this is a good thing. Let's average classic, then row dot v classic dot next f64. So as you can see here, we are directly using this this object. I mean, we are using directly the v classic object, the exponential moving average object. What is that? I mean, this really doesn't need an else block, I think, and this definitely doesn't need one. So the same here. Yeah. Okay. So now we need to previous classic, previous contracts, contracts. Yeah, there's some naming here. Previous other. Of course. Wait, we can actually do. Sorry. Okay. Wait, UA application. Okay, so I'm just gonna continue. I'm not sure what you're saying, Morgan, here. But yeah. Yeah, thank you. I mean, I honestly thought this was gonna take less, as, I mean, given that I've been working with XDR so much, and I've built the product, but yeah, this definitely makes me understand that there's some need for finding a way to make the whole workflow more, to make the whole workflow easier. So now we actually have our updated row, and we just need to update the database. We can pass here our row, and then we have to make the update conditions. And this part is something we haven't tackled with macros yet. So we are going to write this really. We are going to write this as if there was no macro. Where was it? Left. So we are checking. I mean, we want to update the row. So let's actually store. Let's actually store this. Business string. one. Oh, yeah. Again, given that there are no macros here, the whole flow is quite I mean, this is one of the sorry, we have to also serialize this one in order for it to work, and we need to no. Yeah. This is a vector, so let's leave it as is. Okay. It's nice to see. No errors or warnings here. So I believe that this should pretty much be it. Let me just zoom out 1 second to let's make sure with a more clear. Yeah, I mean, I can't wait to see this actually running and working, honestly. But so yeah, I mean, this sounds correct. Yeah. Yeah, I better hope it does, because if not, we're gonna be stuck here forever. So, okay. We actually have to fill all of these columns. And then we have classic. And note here that as a type for now, we only get to use bytes. Everything gets serialized to bytes, and I mean, everything gets serialized to bytes, and there isn't really an implementation on the host level in the database implementation to work with other types directly, like numbers. But this is something that we have in our pipeline. I'm actually using for serializing the bean code crate. So like pretty much any serializable structure, any struct that implements Sardo's serialized rate can be converted to bytes. I'm not sure whether how they're actually converting it to bytes. Though when I first researched this, I do remember at least that it was quite an efficient approach. But yeah, it should work. So okay. So we have here. Okay, so the nice thing about what we have for now is that if I just run this command, everything should build and deploy quite atomically. So let me actually also connect to the server to inspect how this is doing. And I actually believe that it's working. Let me. Okay, so this is the moment of truth. It should be working. So as you can see here, let me take my editor here. Okay, so as you can see here, we have. Okay, this is our table. This is the hash of our table actually. So let's do. Yeah, here, right. That's This is 7. Ah, okay, it's working. Thankfully, it's working. So we have here. This is our it's our row that gets continuously updated. This is byte 64 encoded data. So yeah, basically what what happened here is that pretty much we have all the data that we need in the database, and for this to make the decoding faster, I have prepared this trunk, very simple trunk web app. So and note that this is something that you can actually try. That you can actually try this one for yourself. This one will be a public index, though. Yeah, I mean, though I'm not seeing it for some reason. Oh no, okay, yeah, we have 32 transactions here, and we have here one Sarban transaction. So for the whole period this program has been running, we have sorry, we have how many were the 32 operations and so on. So now if we actually do want to see, because as what we could have done actually, I think that in the example that I will push to the examples repo, I will do that. What we could have done is to keep the object, the exponential moving average object, the exponential moving average object, and that's needed because of course it has it has probably like 2 or 1 parameter if it is an exponential moving average that needs to be stored. So this object needs to be kept unless we want to rebuild it every time. But we also could have directly used, wrote an additional column for this, because now what happens is that we need to add this crate here, and in order for you're saying, Morgan, like period like infinity from from the start of testnet. Yeah, so this is something that I don't know if you remember from the presentation. I said that we were going to implement catch-ups. So implementing a catch-up also would mean that the Zephyr programs that you run can be run even if necessary from Genesis Ledger. So we don't have that as of now. I could manually do this if needed, though. The testnet reset hasn't been that much time away. So you have 64 ledgers. It is an exponential moving average, right? And the period is 64 ledgers. But the average, the total data, it's for all the ledgers, to infinity since the execution of this program, right? But for the average fees themselves, the most significant period is the last 64 ledgers for calculating this. So anyways, I wanted to show you, yes, here, theoretically, if, yes, Okay, so this is the current, which is somewhat. I think that we actually had to change this to F64 since the beginning, because yeah, for Soroban they work because they are much larger fees, but for Classic, I'm afraid that this is not correct. Yeah, this is definitely wrong. I mean, for Soroban, this works. Let's actually just change this on the fly, because this shouldn't take long, so that tomorrow we can. Yeah, yeah, no, of course. I'm just wrapping up. I mean, if you guys need to leave, okay, great. So, what happens here? Let's just change this to an actual floating point number division. Nope. Okay, so now it's just really about this number being normal, right? Yeah. And the same thing goes here. Okay, so we now can redeploy this very quickly. Another thing that is likely going to change is that as of now, all of this data it was just wiped out. All our previous data, we could have prevented this by changing the table name and the columns and so on, but I mean that there wasn't the need. Okay, so assuming that everything is working correctly again, yeah, this of course won't visualize this object. Okay, so we have here Soroban. Okay, so for example here you can see the average fee for Soroban, which is I mean 1, 4, 3, 4, 6. It's like 0.01 stroops, which is quite expected. Also take into account that the whole I mean on testnet fees are generally higher also for Classic. though. Yeah, that's your point. I think that we might have missed some really small stuff when dealing. Yeah, I divided the by the wrong thing. I mean, if you guys want um to exit the stream, I mean, I'm just gonna redeploy this with the correct things so that it works correctly now. But yeah, so this is I mean, I'm quite surprised that there are still 17 people in the audience. You're some brave. Yeah, I mean, you're you now earned some Psycho Labs NFT. I don't know, but yeah, I mean, like, thanks a lot for sticking around. I definitely like it. It means, yeah. So now you can see that this works correctly. So this is the average fee, taking into account that I believe that on mainnet it would be around half of this. But yeah, I mean, if some of you guys had any questions, of course, this is I'm actually going to share the query and also like some more standardized trunk up probably to. Yeah, of course. Yeah, thanks a lot, Morgan, for participating, being also like so active within the call. So yeah, for sure. Let's connect. Again, this is still very raw. I think that Tyler, who was here previously, can well, he can also do a test to how much this has progressed. And you can ask him later. I'm not lying here. And yeah, so you can ask him how much this thing has actually progressed in the last few weeks. And now that we have Mercury ready, it's more stable. It's ready to work with also Freighter on I mean for mainnet and so on. So with all this stuff sorted out, we also have more time to advance in the development of this, make this more suitable for folks to run, because I assume that as of now, people who want to implement this kind of stuff will need a lot of help, of course, from me probably to actually implement these things and see testing and so on. But I'm quite hyped for this, especially because having all of this within a virtual machine enables, I mean, for pretty much endless possibilities for customization and other features in the future. But yeah, I mean, if you guys have any other questions, if not, we can. Yeah, thanks everyone for attending.